Hello everyone, and welcome to this tutorial about machine learning using TensorFlow. This is part 2 and it's about tensors. Before we get into tensors and programming in TensorFlow, let's take a look at how does it work. Some basics about TensorFlow. There are a few concepts that you should be familiar with. TensorFlow executes your code inside an execution engine that you can communicate with using an API. In TensorFlow, your data is called Tensor, that you can apply operations or ops to. Your code is converted into a graph that's executed inside an execution engine called a session. So your Python code is just a representation of your graph that can be executed in a session. This is your Python code. So in here I have few variables or constants basically, and I'm doing a mathematical equation where I'm multiplying a by b and adding c to it and running this operation inside a session. This actually translates into a graph. You can see in the graph that you have both of your tensors, tensor A and tensor B, going into an operation, which is a multiply operation. The output of this operation goes into another operation, which is an add operation that takes two tensors, the output of the multiply and c, to do this operation. You can see how your data or tensors flow from one operation to the next, hence the name TensorFlow. Since version 1.5 and as of version 1.0, there are two methods to execute code in TensorFlow: graph execution and eager execution. The main difference is graph execution is a type of declarative programming, and eager execution is a type of imperative programming. In plain English, the difference is graph execution defines your code as a graph and execute it in a session. So you're declaring your program before you run it. Your objects in Python are not the actual objects inside the session that's running. They are a reference to them only. Eager execution executes your code as you run it, giving you a better control of your program while it's running, so you're not stuck with a predefined graph. You don't predefine a graph and run that. With eager execution, your variables are your tensors, so you can really control how does your program run. So why do we even bother with graph execution if eager execution is much better? Performance is a big issue in machine learning, and a small difference in execution time can save you in a long project weeks of your time and thousands of hours of GPU time. Support is another issue. For now, there is some features of TensorFlow that do not work in eager execution, like high-level estimators. We will focus in the following tutorials only on graph execution, and we'll cover eager execution later in the series. So let's start with the tensors. Tensors represent your data. It's a scalar variable, or whether it's a scalar variable or an array of any dimension, it's always a tensor. Tensors are the main objects to store data, pass it between operations. The input and output of all operations are always tensors. Tensors shape and rank. Tensors have a rank and shape. So for a scalar value, we use rank 0 with an empty shape for that tensor. Assuming you want a variable or a constant number to use in your software, you can represent that in a tensor of rank 0. So if you have just number 3 that you want to represent, it's called the scalar, and it's rank 0, and it has an empty shape. So for rank 1 is a vector or a one-dimensional array, and the shape in here represents how many items do you have. So shape 3 will have a one-dimensional array with 3 numbers. A rank 2, it's called also a matrix. Oh, by the way, this is called a vector. So a one-dimensional array is also called a vector. Two-dimensional array is also called a matrix. It has a rank 2, and it has a shape that goes 3 by 2, so 3 rows by 2 columns. Rank 3 tensors are tensors which are three-dimensional tensors, three-dimensional arrays. They are of rank 3. This you can use three-dimensional tensors usually to represent images. So an image which is 256 by 256 pixels, and it has RGB channels. It will be 256 by 256 by 3. That will be the shape that you use for that tensor. TensorFlow allows tensors in higher dimensions, but you will very rarely see tensors of rank exceeding 5, which is going to be like batch size by the width, by the height of that video, by the RGB, which is like the 3 RGB colors, by how many frames do you have in each clip, which represents like a batch of video clips. Importing TensorFlow. Let's import TensorFlow and start working with some tensors. Graph execution. TensorFlow executes your code inside a C++ program and returns the results through the TensorFlow API. Since we are using Python, we will be using the TensorFlow Python API, which is the most documented and most used API for TensorFlow. Since we're using graph execution, there are two ways to create a session, which is just a session, regular session, and an interactive session. The main difference, an interactive session will put itself as your default session. So since we're just using one session, no need to create a regular session. We can just create an interactive session. So let's create one. Generating new tensors. Since we have interactive session, let's create a tensor. There are two common ways to create tensors, which is tf.zeros and tf.ones. Each one of them takes a Python tuple or an array as the shape of that tensor. So let's create a rank 0 tensor in here. If we evaluate that, notice that the name of our tensor is not actually A. It's just zeros, colon 1. This is stored in A, but inside the graph it's just called 0, colon 1. And we didn't get the actual value of A in here. To get the value of A, you have to evaluate A. So actually you have to run that graph inside your session. So that eval will return the value of your session. One important thing, if you're not using an interactive session, if you're using a regular session, you will have to pass your session in here. So you will have to pass a session in here, your regular session in here. But since we're using the interactive one, it sets itself as the default one, so no need to pass it. You should know that eval method returns numpy float 32 or whatever the type of your tensor. If the rank of your tensor is not 0, if it's anything higher than 0, 1 or higher, it will always return numpy in the array, which is a n-dimensional array. Quick thing about NumPy, it's a multi-dimensional array library for Python that runs operations inside a C program and interfaces back with Python to ensure fast array operations. I have a tutorial about that on my channel. You can go and watch that to know more about NumPy. Now let's check the shape of this tensor. You can see it's just an empty shape in here. If we want to get the rank, The rank is basically the number of dimensions, so it's rank 0. Notice the name inside TensorFlow execution engine is not A, it's 0 colon, which we already talked about, which is just an auto-generated name. The first part of this name comes from the function that generated the tensor. So in here you can see we generated it with zeros, so the name is zeros, and this 0 is the index of that return. So if 0 is returned like 2 or 3 tensors, the first one will be 0, second one will be 1, and so on. So let's see the name of this. It's 0's colon 1. Now if you created another tensor using the same operation, it's just gonna append _1. We can see that in here. So 0's _1 colon 0. If we do that again and again, we'll get like _2, _3, _4, and so on. Now let's create a second tensor of shape 3, and this time we'll pass a name. We'll pass a parameter called name, and we'll call it name b, and we'll store it locally in a variable called named b. So it's easy for us to keep track of names inside the graph and in our software. Now if we get the type of this tensor, it's once we evaluate it and get the type, it's an ND array, an numpy.nd array. There's another way to evaluate your tensors is by calling the run method inside your session and passing any tensor to it. That will evaluate and give you the value of your tensor. You can also pre-fill your tensor with any other value except 0s and 1s, because for 0s and 1s you can just call that method. You can use the method fill, so you can pass the shape of the tensor that you want, and you can pass the value that you want. So in here 2 by 2 with value 5 will return this for us. Notice the data type in here is int32. This is because we passed an integer in here, 5, not 5.0. If we passed 5.0, this would have been float 32. Tensor shape. Tensor shape for multidimensional tensors, the shape is passed as a tuple or an array. The way this array is arranged is from the outermost dimension to the inner dimensions. So for a tensor that should represent 10 items, and each item has 3 numbers, the shape would be like 10 by 3. So let's see how does that look. We have 10 items in here, and each item has 3 numbers inside it. Quick note in here, this is the opposite of how matrix shape notation is written in mathematics. In a matrix shape of a 3 by 10 can be represented in TensorFlow as 10 by 3. The reason for that, in mathematics the shape is column by row, and in TensorFlow it goes outer, then inner, then inner, then inner. So for a 2D tensor, it's gonna be outer, which is the outer part, which is the rows, then the inner part, which is the columns. For higher dimensions of the same rule applies. Let's say we have let's say we have 2 items, and each item has 3 parts, and each part has 4 numbers. The shape would be 2 by 3 by 4. So let's see how does that look. We have 2 items, and each item has 3 parts in it, and each part has 4 numbers inside it. Generating tensors with the random values. It's really common to generate tensors with random values in machine learning. So the first generator of random values is the normal distribution. Normal distribution, the function for that is tf.random normal. I will generate a single dimensional array in here with 1000 numbers. You can see that we already generated this one. This function returns random values using normal distribution, also known as Gaussian distribution, or informally called as bell curve. To better understand it, let's first look at a graph showing this distribution. In mathematics, a normal distribution of mean mu and standard deviation sigma is denoted as n of mu and sigma. More about that later in the last section called the math behind it. To do that, we use matplotlib in here, so you can see how does this looks like a bell, and you can see the mean of the number. Most of the numbers are around number 0, and as further and further you get away from 0, you get less and less numbers. We can also change the mean by passing a mean parameter in here. You can see now the average or the mean of your numbers is 20, and it has the same bell curve shape. You can also control how far your numbers are distributed away from the mean using the standard deviation. So as a higher standard deviation means less values around the mean and wider distribution. So let's take a look in here. We have two tensors, one with a standard deviation 1 and one with standard deviation 2. You can see the one with standard deviation 2 has a wider distribution than the one with the standard deviation 1. One more note about normal distribution. If you are generating a lot of numbers with random distribution, there is no guarantee that they will fall within a specific range. They can fall anywhere. They can really fall away from your mean. So to control that, we use a function called truncated normal instead of random normal. This is really important in machine learning because numbers which are really away from your mean sometimes cause numerical instability in some algorithms. So if we do the same thing, you can see numbers are always falling within, they're truncated to only 2 standard deviation from the mean. Uniform distribution, it generates numbers that have equal probability of falling anyway between 2 numbers, so between 0 and 1, and you can see it's roughly the same number in here. It doesn't have that bell curve shape to it. Generating a number with sequenced value, so we use the function called range, and we can pass how many numbers we want. So it will return 0, 1, 2, 3, 4, 5 numbers, which is also equivalent to passing the first number you want and the last number. Always notice that the last number you will is a limit, so you will never reach the last number, so it will give you 0, 1, 2, 3, 4 only. It will not show you 5. You can always pass a third one, which is the delta, so you can have only numbers with a delta of 2, so it will skip every time 2 between these numbers. Reshaping tensors, you can create a tensor with 6 numbers and then call the reshape function and give it a new shape. So in here I reshaped it to a tensor that has the shape of 3 by 2. Tensor arithmetics, we can add tensors, so we can create a tensor with the ones. So the first tensor is all ones, and the second tensor has is filled with 10, and the shape of these is 2 by 2. So 1 plus 10 equals 11. Element-wise operations, we can multiply our tensor by any scalar number. So in here I'm multiplying it by 2, so 11 times 2 is 22. You can also add element-wise, so it will add a 3 to each number in here, and it will be 22 plus 3, which is 25. Matrix operations. There are so many matrix operations supported in TensorFlow. We'll go over a few of them. So one of the common things that you want to do sometimes is create an identity matrix, and an identity matrix is a matrix that's all zeros with only the diagonal line in here filled with ones. The function for that is called I. So I of 3 by 3 will create a 3 by 3 tensor with diagonal filled with ones, and the rest of the values are zeros. Transpose is a very common operation that we use, and it converts your rows into columns. Assume you have a matrix A, and a transpose operation over this matrix produces A with the T on top. It's pronounced A transpose. So let's take a look at this. We have in here this tensor that has 2 rows and 4 columns. If we transpose it, it will have it will convert our rows into columns. So we can see 1 2 3 4 becomes as a row becomes 1 2 3 4 as a column. Matrix multiplication. This is the most common operation for matrices in deep learning. Matrix multiplication is not element-wise. So if we multiply two matrices, we're not multiplying the first item by the first item, the second item by the second item, like adding. The exact math will be discussed at the last section of this tutorial, the math behind it. But for now, I will give you some basics so you can follow the rest of this tutorial. Assume we have two matrices A and B. The shape of A is n by m by n, and the shape of B is O by p. We can write these two matrices with their shapes as A of m by n and B of O by p. Multiplying these two matrices produces a matrix of shape m by p if n equals O. This will be much easier if we see it in here. Multiplying A by P, A by B produces C. The C has the outer shape of both matrices, and this only applies if the inner shape is the same. So only applies if N and O are equal. Notice the inner shape of the two matrices is the same, and the outer and the product of these two matrices has the outer shape M by P. If the inner shape is not matching, the product does not exist. We can use matmul function to do that. Let's do that in TensorFlow using the matmul function. You can see we created two tensors in here, A and B, of shape 2 by 3 and 3 by 4. The inner shape of both of them is matching, so 3 and 3, and the output is going to be 2 by 4, and you can see in here C has the shape of 2 by 4, and you can see that it does actually has the shape of 2 by The math behind it. Let's start with the standard deviation. Standard deviation is the measure of how elements set vary from the mean. Basically, standard deviation, higher standard deviation means the numbers are really spread away from the average. A very low standard deviation means all the numbers are very close to the average. So this is the formula to calculate standard deviation. Let's break it down and see how to calculate standard deviation. We'll just take an example in here and try to calculate the standard deviation for that. Assume you have exam grades for 10 students, and the grades are as follow. So in here you have grades of 10 students, and these are the grades. So you can see the lowest one get like 71, the highest one maybe get 98 or something. Yeah. First thing we need to do is calculate the mean. The mean is denoted as an x with a line on top. It's pronounced x bar. To calculate the mean or average, get the sum of all the numbers and divide it by its count. So just get the sum of all these numbers and divide it by its count, which is 10. So let's calculate that. These are our values in here. So I will first get the sum of all of these values, and then I will get the length of this array, so the sum of how many students I have in the class, and my mean is gonna be the total or the sum divided by the count. So my average in here is 87.8 for this class. Now that we know the mean, we can go back to our original equation and calculate the standard deviation. So let's take a look at the equation. It's just the sum of each student's grade minus the average of the class squared. Then you divide that by how many students you have in the class and take the square root of the whole thing. We can do that step by step. So we can first go and get each student's grade for x and g, which is the list of all the grades, and we can do this part. So subtract the student's grade from the class average and take the square of that. And we will take the sum of all of these differences. We'll put it here in a variable. We will divide that by the count, which is how many students we have in the class. This is called the variance. If we just take the square root of that, it will it's called standard deviation. So let's we can write that in a single line in here. And let's calculate it. The standard deviation of this class is 8.09 or 0.1 actually, if we round it down. It's 8.1. Note that the standard deviation is a built-in function in NumPy, and TensorFlow, and many other languages and libraries. So in NumPy you can just do mp.std of g and it will calculate the standard deviation for you. But it's kind of fun to know how does standard deviation is calculated from scratch. Never calculate it from scratch because these libraries can do it more efficiently basically. You can also do it in TensorFlow. So same thing in here. I just converted the grades into a constant and took n at moments, which returns the mean and the variance. If I take the square root of the variance, I will end up with the standard deviation. So the second thing we want to talk about quickly is variance, which is denoted as sigma square or s square, or sometimes even var of x. It's just the square of the standard deviation. So if you don't take the square root of your the variance, you end up with just the variance. That's kind of obvious. The variance of this class is 65.56. Matrix multiplication. I promised to explain that at the end of this tutorial. Assume we have two matrices in here, A that has the shape of 2 and 3, and B that has the shape of 3 and 2. So first of all, we check, is the inner shape matching? Yes, it's 3 and 3. What's gonna be the output, the product of these matrices? It's the outer shape, which is 2 by 2. And here, this is an example where we have matrix A and matrix B. C is gonna have the shape of the outer shape of its of A and B, so it will have the shape of 2 by 2. The way the calculation is done is you take the first row and first column, multiply the first item in here. Actually, let's wait for the animation in here, which will explain it much better than I can do. So you take the first row and first column and first row, and you start multiplying numbers, the same number. So first number, second number, third number, and you take the sum of your elements in here, and that's your the output of your matrix, dot product of your matrices. So let's confirm that in TensorFlow. So I just rewrote my matrices as arrays in here, A and B. But remember, before we proceed, that in mathematics, matrices are the shape of matrices is opposite of what we have in TensorFlow. So what we wrote in here should be, these rows should be columns and columns should be rows for this to work. So we can just use transpose for that, and we can evaluate that, and we can see 7, 10, 10 and 16 matching our output in here. Luckily, there is an easier way to do that. So instead of transposing each one of them separately, you can just pass a parameter in here to matmul called transpose A and transpose B, and you can evaluate that and you will get the same value. Quick quiz. I have two matrices in here. A shape 1 by 3 and the values are 1, 2, 1, and B is 3 by 1 and the values are 2, 1, 2. What's the dot product of A and B? If C is the dot product of these two, what's the value of C? For the first person to answer this math quiz, I will send you a t-shirt, the iTrain t-shirt showing Tensor going through an algorithm to be trained. Some comments from the last videos. Abdullah said, thanks, one of the best tutorials I've watched, keep up the good work. Thank you, Abdullah, and I will keep producing these, and I will put as much effort as I can in making these videos. Stacy Purcell said, well done, I really like the pace and scope of this introduction. It provides long, smooth run way to the basic concepts. I really appreciate the explanation of the mathematical notations too. Keep up the great work. Thanks, Stacy. And thanks for giving me feedback about the math part of these tutorials. I'm planning to keep pushing with the math parts in these tutorials, and keep introducing more math concepts in these videos. This tutorial is available online on GitHub, and it's open source under GNU. Use it for any. That said, thank you for. I hope if you like this video, you will subscribe to this channel. And if you missed the last tutorial in the series, which was about machine learning basics, you can click the link right here. And if you want to watch the next tutorial in this series, click the link right here, which is about variables. If you have any questions or any feedback, you can leave a comment under this video or contact me on Twitter at Twisted Hardware. And if you really like this series, you can buy the Tensor iTrain t-shirt from teespring.com/store/Roshan. Thank you for watching, and see you next time.